So how does a Node MCU module looks? How do you program? So I have a board with me. I'll show you how to program it so that you can go today only. You can go to purchase one such board. You can start experimenting today so that it will be easy for you to understand for the tomorrow session also. So let's learn that one. If at all, if anything is available in the market which is suitable for IoT and which is a low cost, low power consumption, you can run from a battery, keep it for a month together, throw that module in the field and leave it like that and access the data, that is called as Node MCU module or ESP8266 module. Do you know what is the cost of it? It's for 250 rupees or 300 rupees, you get this module. Even normal microcontroller Arduino board, you know that Uno board costs about 300 to 400 rupees. And that do not have the Wi-Fi facility. So what is the difference between your Arduino board, which is used as a microcontroller by most of you in your projects? An Arduino use a small board where a microcontroller is present. So what is a microcontroller? A microcontroller is one which has got a CPU, which has got a memory for writing the program, memory for storing your data, and which has a GPIO pins, that is input output pins, which has got some analog input output pins. So to interface the sensors, all this put together, you can call as a microcontroller. So microcontroller is nothing but a CPU surrounded by the flash memory, the data memory, GPIO, analog, input output. These are all called as whole set of things. If you provide in one chip, so that we call as a microcontroller. But what is the lacking of Arduino? Yes, if you are building a smart system which is not connected to anything, for example, refrigerator, you take a washing machine, you take a microwave oven, normal, what is available in the market nowadays. That means that they require some microcontroller like Arduino. Through that, you can able to program all these things. That is washing machine, your refrigerator, micro oven. Then microcontroller is good enough because you program that, you are able to access it. But if you want little more value addition, that means that I want to see that how my washing machine has performed. That means that in a month, how many washes have performed. If there is an emergency in the washing machine, that means that something goes wrong in the washing machine, can I get a message on my mobile app so that I can automatically take a call to a service center, or it can be made intelligent app. It can immediately place a call to the service center and get it repaired. I want to see that in the refrigerator, how much items are there so that I require a buying for the goods or not. So today before coming home, automatically I can place an order to a store so that before I come home, all this has been available. I can just put them, stack them into my refrigerator. So like these are the things, value additions you want to give to the existing products. Then Arduino is not sufficient. You have to have a microcontroller, of course, what is there in Arduino board, plus you require an extra facility. What is an extra facility? Getting connected to the internet and getting connected to your mobile application, getting connected to your web application. That means that you should have a facility to make it connect to other applications, other hardwares in the network, and so that user can sit in a remote place, can able to see what's happening. So this providing a network connectivity to your microcontroller over the net is called as basically enabling the microcontroller boards as what is called IoT enablement. Basically, what is an IoT? Sitting somewhere, you can able to guess or get some data from the sensors. Sitting somewhere, you can able to actuate some device, giving a command through your web app or the mobile app. So that is basically IoT enablement. So ESP8266 or the Node MCU is Arduino-like microcontroller, plus it has got what is called as Wi-Fi capability. So this Wi-Fi capability is the one which makes it suitable for using in the IoT domain. If somebody asks, what is the difference between the Raspberry Pi? So let's not look at the Raspberry. What is the difference between Arduino and the Node MCU or ESP8266? You can tell them that ESP8266 is also microcontroller. It has got what is called as Wi-Fi capability. Since you have a Wi-Fi capability, you can connect to the router and to the internet and make it IoT capable. So that is where the ESP8266 or Node MCU is different from your Arduino board. So what can you do with these modules? You can create a web server, you can send the HTTP request, you can control the output, you can read the inputs and interrupts, so you can send emails, you can post the tweets. These are the things what you can do with the Node MCU board. Now we will, once understood what is the basic difference between the Node MCU and Arduino, we will start using them and we start interfacing devices to the Node MCU and start learning the programming. So now we'll go to the specification of ESP8266. So some of the specifications we'll learn as we progress it. Now, just for the moment, we will understand that ESP8266 is a 32-bit CPU. So if somebody asks what is a ESP8266, ESP8266 is basically has inbuilt 32-bit microcontroller. It's a 32-bit CPU which has got the Wi-Fi capability, so which has got integrated TCP/IP protocol stack, so which enables lot of software you can avoid in programming. You can just use them. You can write the basic codes, because why? The protocol related code is already present in the ESP8266. So the Wi-Fi capability, and also it gives the protocol stack. So when I say stack, what does it mean, the word stack? So set of procedures, a set of library functions has been developed. If I don't have this stack inbuilt, when I write program, I should have that libraries in my program. So I should import the libraries. I should have understood what is how the library works, everything. Now, when I have this protocol stack or the program built in the chip itself, it's very easy for the programmer. You can just start writing the code immediately. With the 10 lines of code, you can connect to the internet. Earlier days, it was impossible to just use 10 lines of code to connect to the internet, because you should have required stack was required. Now it has been inbuilt to that. Now, this chip, now we have understood in a better way now. What is the ESP8266? It is a 32-bit microcontroller. It is a Wi-Fi capability. It has got TCP/IP stack in that, so that programming will be easy. So let's learn more about that, a little more about. Now, how does the ESP8266 is available in the market? So if you order ESP8266 chip, this is what you get it. So this is the microcontroller chip, and this is the Wi-Fi, that is the antenna on the PCB, on the antenna, the PCB. So the antenna is there in the PCB. So this is the antenna, through that the Wi-Fi transmission happens. So it works in 2.4 gigahertz, so ISM band. Now, so this is the chip, microcontroller chip. So it's like your Arduino Atmel 328 chip, whatever there in the Arduino board, like that chip. So if somebody asks, so this is not the board. ESP8266, when I use the word, when I just say ESP8266 is nothing but what? It's an IC. It's an IC which has got a microcontroller, which has got Wi-Fi capability. So you can have the antenna on the PCB, and inside the chip there is a TCP/IP protocol stack has been implemented. Now, what does this chip contains? This chip provides, along with this facility, that is facility of Wi-Fi, it provides the microcontroller capabilities. Any microcontroller should have what? Three things should have it. Number one, it has got a GPIO pins. So now we can see on the board, on the figure, there's a lot of GPIO pins are there. How many GPIO pins will be there? There are 11 GPIO pins are provided in the ESP8266. If you count it, including this, leave this one. This is for a SD card. So this is for the SD card. You can count for this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 GPIO pins are available here. Now, these 11 GPIO pins are digital pins. Also, they can be used as PWM pins. That means that you can simulate analog output using these pins whenever you want to generate a varying voltage, which can be connected to a motor or any actuator. So apart from these 11 GPIO pins, what else will be there in this ESP8266 module? This ESP8266 protocol, it also support what is called analog interfacing. So now, in case of Arduino, can somebody tell me how many analog inputs are there in Arduino Uno board? Can somebody tell me? Probably you would have worked on. How many?
6.
Exactly. So 6 analog input has been A0 to A5. But in case of ESP8266, only disadvantage is you have only one A0 pin. That is one ADC input is available. So if somebody asks, can I use a Node MCU? I have 4 sensors are there for my project. I'll say no. Because why? You have only one ADC input is there. Better use an Arduino and then connect ESP8266 to the Arduino for Wi-Fi connectivity. So now onwards, you should be in a position to decide for a project which I can use it. Can I use ESP or can I use an Arduino? Always, when the number of analog inputs, for example, I'm monitoring a temperature, I am monitoring a weather. So I am monitoring one sensor or other sensors are I2c compatible. Then you can go for this one. Identify how many analog inputs are required for your project. Based on that, you can choose whether you go for Arduino or go for a ESP8266. So ESP8266 provide only one analog input. So it has got 11 GPIO, one analog input is there. And then ESP8266 provide all the standard serial protocols supported in an embedded system. If somebody asks, if you are embedded system designer or you're prototyping embedded systems, you should always understand that what are the popular protocols to be supported in embedded system. This is very important. There are 3 serial protocols will be supported by most of the state-of-the-art microcontrollers or smart systems. Number 1, we should provide what is called Uart. So Uart is nothing but asynchronous serial communication, where for every 1 byte of data, you send a start and a stop bit, and the speed at which you push the data from the microcontroller to be decided by the programmer who writes a program here. People generally use baud rate of 9600 for a minimum or a maximum of 1,15,200 baud rate. Baud rate is what? The data at which you're pushing the data. So serial protocol means I am transferring the data from this microcontroller, or I am receiving the data from other intelligent devices around this using the serial fashion, 1 bit at a time. So TXD means transmit data. I am pushing the data. RXD means receiving the data. This is a TTL compatibility. TTL means when the data is 1, your output is what? 3.3 voltage or 5 volts. Whenever the output is 0, logic 0, the digital voltage is 0. Many times you require to interface to the GSM module, GPS module, which comes with a RS-232 standard for a asynchronous serial communication. In such cases, you have to provide an interface here, what is called as RS-232 translator or MAX232 chip. You have to use it. Then you have to send the data to RS-232. Summarizing, the Uart or the serial protocol can be TTL compatible or can be RS-232 compatible. You have to see that where you are connecting this Uart. If it is a connecting to Uart which is TTL compatible, connect these 2 lines directly. If you are connecting this Uart to RS-232 compatible serial port of a computer, use a translator and connect it. This is what is the knowledge, you should have it. So this is the first protocol. So first serial protocol is what? The Uart. Uart is the first serial protocol which is very much essential for any embedded system project. All your GSM module, GPS module, and most of the RFID readers, they provide what is called Uart interfaces. So Uart interface requires 1, 2, and the ground line. So 3-wire communication. It's also called a 3-wire. If you provide a handshaking, it can be 9-pin also. So nowadays, nobody uses handshaking, hardware handshaking. We just use 2 lines and use a software handshaking. When I say software handshaking, there is an understanding with this system and another system where you communicate through the program. So you know that you have written the code here also, you have written the code here also. So then you know that how, when do you get the data, what is the termination of the data, all these things will be understood by the program which has been developed here and the remote place. Now let's go to the second serial protocol which is commonly used in embedded system. It is called as I2c Protocol. What is the disadvantage of the first protocol, Uart protocol? Why I should go for I2c? I2c removes the disadvantage of UART. What is the disadvantage of UART? If I connect TXD and RXT, UART, to a computer, finish. I cannot use the same channel or the TXD RXT to connect to another computer. It's finished. It's not possible. Let's say you have GPS and GSM module. If you connect to the GPS, you cannot connect to the GSM module. It's basically 1-to-1. You cannot say 1-to-many. The same lines, the protocol does not support multiple devices. You can say that one master or one slave, or you can call it a master slave. So one-to-one device connection is there. Multiple devices I cannot connect on this bus. So that is a limitation of that. Even though the speed of TXT-RXT is good enough, 1,15,200 is a good enough, which almost matches with an I2c, the latest TXT-RXT speeds. But still, since because of one-to-one, so people will avoid using TXT-RXT for a certain set of devices. Now, but wherever, for example, if a computer, I want to upload the data what has been stored in this Node MCU module to a computer, I've been deployed this on the field. So once in a month, I'll get this module, I'll connect to my laptop, upload the data. So which is better? Use TXT-RXT. Then I2c is not used or SP is not used. Always you should remember for what purpose, what protocol to be used. If you're uploading the data or downloading some information from a computer to this one, always we use what is called Uart only. Uart is meant for uploading or downloading of data to your laptop or a PC. So always see that what is the scenario for which serial protocol you are supposed to use it. So for example, so I want to upload the data to the internet. Yes, of course, we will use the Wi-Fi, and this TXT-RXT can be used to connect. So see the scenario and then decide which serial protocol. Now let's come to the I2c protocol. I2c protocol, as the same name says, I can use the same bus and connect to multiple devices. You can hook multiple devices to the same bus. So let's have 4 sensors are there, I2c based sensors. I can connect all these 4 sensors to here. Only thing is what? Maximum 128 sensors you can connect to the same bus. Each sensor should have a different address, so that with a unique address, I can talk to these devices, I can collect the data, or I can send some information to these devices which are connected to the I2c bus. I2c bus also supports around same or little more speed compared to the Uart. So when you use I2c, whenever the sensors you purchase or the gadgets, whatever you purchase, if there's a facility called I2c is there, so you can go for I2c. But whenever you have an I2c module, start using in your project, just please check the first in the datasheet, what is an address of this I2c device. The backside, there is a jumpers are provided in most of the I2c sensors. You can configure by 1 or 2 addresses, 78, 72, 82, like that. Why they are given a jumpers? Because if you want to connect 2 sensors, 2 same sensors, or 2 sensors, whatever you purchase in the market, I've got the same address. You cannot both of them, because you can have only one sensor of a particular address among the 0 to 127, that is 128 addresses. What should I do? Take the board on the back side using a jumpers, configure them, one for one address, let's say 78, another you change it to 80. So that is why most of the I2c devices, whenever you purchase and start using in your project, just put a question to yourself, open the datasheet, see that what is the address of this I2c device which you are connecting to the I2c protocol. So is the 2 devices, if you are connecting more than 1 device, I've got the same address, then change the addresses. So this is one precaution you have to take it whenever you use a I2c protocol. So sometimes we want to add some extra memory which is not there, that much is there. For example, if I have around 32 kilobytes of memory is there, I am just deployed this in a field. I want to capture the data in the field, the moisture or temperature. Let's say internet connectivity has gone. That means that no connectivity is there for the last 2-3 days. So then what should you do? You lose the data. Instead of that, you can connect a data flash memory to this chip and keep recording the data here. Once you get the internet connectivity, just gather the data, whatever there in the flash memory, and then you send to the internet. So always these type of systems, you should always plan to have 2 models of working. If internet is there, throw the data to the cloud. If you know internet is there, you cannot afford to lose the data sometimes. Depends on the project. So where is the facility? So use and connect an SD card, push all the data into that, and then gather that and again send it to the net. How do I provide the data flash interface? So one method is what is called as Spi protocol. The third protocol in the serial communication is called as SPI. So SPI, it is also serial peripheral interface. The beauty of the SPI protocol compared to the I2c protocol, of course, this also you can use this protocol to connect the multiple devices, but this case is there. That means that the CS chip select, it's a part of this SPI protocol. There's a 4 pins will be there in SPI protocol. So in I2c protocol, the 2 pins are there only. The bus is made up of 2 pins. One is called serial data, other is called a serial clock. In case of SPI protocol, 4 lines are there. So one is called a serial clock, mask input, serial output, mask output, serial input, and the chip select. So you can connect multiple devices. These 3 lines will be the same for all the devices. Only the chip select so should be different. So that's how. So you have to use other GPIO pins as a chip select whenever you use an SPI protocol. If there are hundreds of devices are there, say let's say 50 devices are there, SPI you cannot connect it. Maybe 1 or 2 SPI devices you can always connect it by using one chip select for one device, other GPIO as pin as a other chip select. When multiple devices are there, so each one should be given a different address, then always you can go for I2c protocol. The one difference of SPI protocol compared to I2c protocol is the data transfer rate is very high. That is why when you connect LCD, color LCD, that is SPI based color LCD or flash memory, so people always use an SPI protocol because the data transfer is very high compared to the I2c protocol. The beauty of these 3 protocols is that it supports any type of serial communication. Only thing, you should take a decision what is best for the scenario. The only thing is, in case of Uart, the clock speed has to be decided by the programmer here. Because why? There is no question of, so who generates a clock? So clock is not sent along with the data in case of a asynchronous communication, Uart protocol. Unlike in a I2c and SPI, where clock is sent along with the data. You can look at that. Data is separate pin is there, clock separate pin is there. See that masked output serial input. So that means this is the data output. This is the data input. Like it's like a TXT, it's like an RXT. MOSI is like a TXT. MISO is like a RXT. See, here is also clock. That means that both in SPI protocol, in I2c protocol, you're sending the data along with the clock. So that what will happen? The destination device can gather the data or extract the data with the help of the clock. So he did not have the knowledge about what speed you are sending. The baud rate never comes into picture because why? You're sending the clock along with the data. When is the baud rate comes into picture? Only in case of Uart. Because why? You are not sending the clock. You're sending only what? See, TXT, only data you're sending. Then how does the destination device knows that? What is the rate at which you're extracting the data? So for that, there should be an understanding between the sending device and the receiving device. That is, what is the speed at which you send the data? What is the speed at which you receive the data? So these are all the 3 types of serial protocols supported by any embedded system. In particular, ESP8266 also supports. Am I audible?
Yes, sir. Yes, sir.
Okay. So now there's one more interface is available. It is for SD card interface. Of course, you can use SPI also for SD card, but there's only one data line is there. So the communication will be very slow. The 4-line SD card interface, so we call as a SD card 2.0 interface, will have 4 data lines are provided so that writing and reading from SD card will be very faster. So this is how you can interface an SD card and upload lots of data in the field without even the interconnection. So that is why whenever you deploy or design the boards using ESP8266, make sure that if there's a facility there, make a provision for SD card also, so that you can able to keep the data even for a month together. So once the net connection is there, then it can upload the data to the cloud. So summarizing, ESP8266 provides 11 GPIO lines, 1 analog input, no specific analog output is there, but GPIO pins you can use as a PWM pins to generate analog outputs. It supports 3 serial protocols which are popular in the embedded system world. The first is Uart, the second is I2c, and the third is SPI. It provides SD card 2.0 interface so that high-speed SD card transfer can be supported. And also it provides the Wi-Fi connectivity. Through that you can able to talk to the external world. So the form factor is very small. So with a battery you can work for a long time with ESP8266. Now, what is Node MCU then? We have understood now ESP8266 chip. If somebody asks today, what is ESP8266? You should tell that it is a microcontroller chip with a built-in Wi-Fi capability, TCP/IP stack implemented inside, and like a normal microcontroller, It has got a GPIO, analog, serial protocols are supported. It's a microcontroller plus Wi-Fi plus TCP/IP stack. That is a ESP8266 microcontroller chip or ESP8266 Wi-Fi chip. Now, what is Node MCU? So let's learn what is a Node MCU. So these are the pins I have listed here, all the 11 pins. You should be very careful whenever you use the pins. There are certain rules and regulations because you are overlapping GPIO pins with what? I2c, SPI, and Uart. So if you are using Uart, you cannot use those GPIO pins. If you're using I2c, you cannot use those GPIO pins. That means that we are done multiplexing. You can see that multiplexing. There is a alternate functions are there for the GPIO pins. Alternate functions are there for the GPIO pins. So if the alternate function used, you cannot use them as a GPIO pins. So just be careful. So whenever you implement a project, whether you're using as GPIO pin or as a alternate function, and also refer some table which is that as soon as you boot, what is that? The line is pulled low, line is pulled high. Is it always high? If you pull it low, anything happens in the boot time. So there are conditions are provided about the pins. So I'll share this PPT, this material. You can refer that whenever you do the project. What are the precautions you take when you use GPIO pins? Now, this ESP8266, of course, you can use this chip along with the board, other boards. For example, I'm building a project using a Raspberry Pi, or I'm building a project using an ARM microcontroller. I require a Wi-Fi connectivity. I can always use the microcontroller along with the ESP8266. How people generally use it? You have already a microcontroller is there, a board is there, a MUC board is there, which is an ARM-based board, something is there. It does not have Wi-Fi connectivity. What people do is they purchase one ESP8266 chip and connect that board to this microcontroller board and provides the Wi-Fi connectivity. This becomes IoT enabled. That's how people are doing for a legacy microcontroller system. For example, you take an Arduino board, you don't have an Wi-Fi facility, purchase ESP82 chips, connect them using a Uart, and write some small protocol programming. So, and then you can send the data using ESP8266. Where in this case, ESP8266 uses what? Just as a Wi-Fi module. You're not using the features of ESP8266 microcontroller. That means that I'm not using GPIO pins here. I'm not using ADC. So I'm using 8266 as only as a Wi-Fi module. So we call it the AT programming. There's what is called AT commands. I can send it here. Through that, I can able to transfer my serial data in a Wi-Fi fashion outside this board. So ESP8266, one of the best way use is what? Use this chip along with the microcontroller boards to give Wi-Fi connectivity to your boards. But let's say I don't want to waste again Arduino board, connect again ESP8266. Can I go for directly ESP8266 as a microcontroller, as IoT connectivity? Then comes into picture, lot of boards are available in the market. You can look at these boards. So these boards will use ESP8266 chip on the board and provide some other ICs around it, so that I can use this board itself as like an Arduino board or an RPi board or an ARM microcontroller board. So such boards are popularly called as Node MCU board. They're called as a Node MCU kit. They're called as a Node MCU is a word you use it. So the boards which are very popular in the market are ESP01, Nodemcu Kit, or Vemos D1 Mini. So these are there are many boards are available in the market. Many are there. So the popular one I've just listed. So ESP, so 12E, this is the board which is very popular in the market. It's available around 300 to 400 rupees. You can go for this board for doing the projects. Now, so let's understand the Nodemcu Kit. How does it available? So this is the board. This is the Nodemcu Kit, what I have with me. So if I show you, so can you see the board? So this is the Nodemcu Kit, what you're seeing. So you can just look at my video. I'm just showing a small Nodemcu Kit. So this, could you able to see in my video the board?
Yes, sir.
Yeah, this is a small Nodemcu Kit. We call it a Nodemcu Kit or Nodemcu board. This Nodemcu board, you can see that there is a what is called as, so there's a metal is available, and that, so below that is an ESP82. ESP82 comes with a metal shield, and that above that you can also see that there's a what is called as the antenna is on the PCB. So this is the Nodemcu Kit, what is available. Let's understand now how does a Nodemcu is there, how it is different from a ESP8266. Nodemcu has got ESP8266 microcontroller. See that the ESP8266, whatever we studied, which has got 11 GPU, 1 E and everything, is being taken and soldered on the Nodemcu board. So then what else extra things which is there in the Nodemcu board? Nodemcu board has got voltage regulator. In the sense, you can directly plug in your USB, so the mini connector, then using this regulator, it converts the 5 volts to the required voltage required for this microcontroller. That means that voltage regulator is built into that one. So the first is it has got a ESP8266, second is voltage regulator. What is the third one? It has got one LED which is connected to the pin 2 of this one. So this pin 2 is already connected here. So whenever you purchase this board, like an Arduino also, so you know that probably D13, the GPU pin is already connected to what? One LED built in that. So whenever you take an Arduino board, you can write a program to check the board is working or not, the control is working or not. Like that, it is connected to the pin 2 of this ESP8266, the built-in LED. You can make it on and off. So here it is there actually. So that is probably a different one. Here is that LED. So pin 2 is connected here. So whenever you write a program, just test this board is working or not by making it on and off. We will do it now. Now, this is the third one. What is the fourth one? The beauty of the fourth one is how to program this chip. Let's say I have purchased only this chip. Now I have got a computer. How do you program into this ESP8266? Let's say I don't have a Nodemcu. I want to program it. Let's think about this scenario. I have an ESP8266 board. I have got a computer. I have to program this one. How do you program it? The computer has got a USB. The computer, what is coming nowadays, do not have a TXD RXD connection. Then what do you require? You require USB to serial converter IC that you have to put it in a board. You have to purchase a board, and then you have to connect from that board to TXD RXD. That means that whenever I want to interface ESP8266 to a computer for programming, I require USB to Uart converter because computers do not have TXD RXD pins. So the beauty of Nodemcu board if you purchase is they provide Scilab CP2102 chip. This chip is popular USB to UART bridge used in most of the boards in the world today. You take any ARM board, most of the board they use CP2102 drivers. So whenever you use these boards to develop the projects, make sure that driver is installed in your system. Otherwise, just type Scilab CP2102 and that bridge driver is available, install in your computer. So the moment you install this one, you go to the device manager, see that as soon as you plug in this module, so there is a COM port is visible. So that means the driver makes sure that it communicates with an operating system of your laptop and establishes a name, communication, and give a name for this for this controller. It's called as a COM1, COM2, COM3, some number will come. So that means that so the driver is installed. So this chip is inbuilt into this module. So summarizing, Nodemcu Kit is basically a board. It's a development board. It's a microcontroller development board or IoT development board, which has got a ESP8266 microcontroller or Wi-Fi module, which has got an inbuilt voltage regulator, which has got a USB to UART bridges available, so that just plug in this board to a computer through a USB cable and start programming it. You don't require a converter, and it's got a built-in LED to test the program is working or not. All these GPU pins and analog input pins are brought out on the two edges of the Nodemcu module. The pin numbering of this, what is available at edge, is different from the pin numbers on the chip. It's very important when you use it. So don't get confused and say the board is not working. So the pin number is different. These pin numbers are different. Pin 1, whatever the numbers are there, GPU 1, 2, 3, these pin numbers are different. And what is the pin number you have in the Nodemcu module on the outside, D0, D1, D2, T3, Z. These pin numbers are different. So make sure that, so when I'm in the program I'm referring to what? The ESP8266 pin numbers I'm referring it. Because the board pin numbers vary from board to board. There is a number of boards are there. The numbering will be different on the board side. So you should be careful when I refer to pins. So which pin you are referring? Are you referring to the ESP2 pins or the Nodemcu board pins you are referring? You should be very careful. like in RPi also. So the board, the BCM package is different, the board pin numbers are different. Most of the times when you use any development boards, this you should keep in mind, the numbering reference to the IC, controller IC, or the numbering reference to the board. Now these are all the pins we have already discussed. The same pins were of ESP8266, they brought out here and they given a name. Only the position may be different, and not all the boards will bring out all the GPO pins. For example, if you look at the boards here, some boards ESP01, see that there is only few pins are there. They have brought out only one GPO pins. So you should always think that if your project requires only one LED or one device on and off, or read one sensor, it is not required you have to always purchase what is called as Node MCU kit. You can purchase ESP01 kit also. So ESP01 kit will have only one GPO bin comes out there. So for example, if you take MEMOS D1 mini pinout diagram or pinout board, see that number of pins brought out here is less compared to the Node MCU kit. So similarly, if you take ESP826601 board, as I said, you have a converter, everything is available here, but number of GPO pins which are brought out is very less. Why we have to take up this board, this type of board? Whenever the form factor is very less, that means that there is a very less space where you have to deploy this board. That means that this board goes into another gadget and there is no place is that, and it has to run for long hours of duration on the battery, and you don't have that much of GPO pins requirement. Always go for ESP826601. So always decide which Node MCU kit you have to go for. Depends upon where is you're going to deploying it, what is the requirement of GPO pins, how much of power you're going to provide, is the power supply is there, or you just run on the battery. Based on that, you take any one of the Node MCU kit. Node MCU is generally say what? It's a development board based on ESP8266. What is the difference between ESP8266 and Node MCU? ESP8266 is a microcontroller, Wi-Fi enabled microcontroller. Node MCU is what? Development board. So which development you are going to take? Node MCU development depends upon your project requirements. Am I clear? Can somebody respond? You're able to understand?
Yes, sir.
Okay. So anything is there, you can just stop and ask me. Now, having understood the different types of Node MCU boards, and I said ESP01 is one popular board, ESP12 Node MCU another popular board, MEMOS D1 Mini is another popular board. As you can see that ESP01 so has got only 4 GPO pins and 1 ADC pin. That's all, very minimal requirements are there. So even the USB to serial converter is also not provided set. You have to take an external converter. Maybe check whether some has got or not. And as you can look at the form factor, it's a very small size. Whereas look at the 12E ESP12E Node MCU board. So the size is what? Almost double. So you can see that 24.75 mm, here is 48.55 mm. That means it's a double size. So of course, the memory you have more, the GPO pins are more here. So look at the requirement and then choose. So the ESP12E Node MCU has got 4 MB of memory for your program. Now we will start doing development on the Node MCU kit. Now, so we have understood what are the features of a Node MCU kit. So it has got a 4 MB of flash memory. It's 11 GPO lines are there. 1 ADC input is there. It's a 10-bit resolution. That means 2 to the power of 10 minus 1. 0 to the 1023 is the digital outputs you get corresponding to 0 to 3.3 volts of analog input. The board has a built-in voltage regulator, and you can power up the module using USB socket or the V-in pin. Uploading the code on the board is as easy as uploading the code to the Arduino. There is no need for FTDA program. That means that you don't require external USB to UART. The bridge or the programming interface is not required because it is built in the board. So these are the features of Node MCU kit. Now let's start programming the Node MCU kit. So now I have the board is there with me. I have to start programming it. Let's develop few programs on the Node MCU kit now. Now, ESP8266 developing community, developer community, do not provide separate what is called as the application program or programming environment. So the beauty of the ESP8266, why it's very popular, why it's popular means this community has created an add-on on the Arduino IDE itself. That means that if you know Arduino, the same IDE you can use it, the same style of programming, that is C++, you can use it to program the Nodemcu Kit also. That is why it has become a very popular. Now let's learn that. So hoping that I know the Arduino IDE, how do you work on it? So you can see that I've already installed the Arduino IDE. So there's something, so this is Arduino IDE. Probably you would all used it. So this software you require to work on it. We will see that how do you start work on it. Now, step one, what is required? If at all, if you have a old Arduino, they say that 1.6.4 and above versions work way better. See that it's better, always install the latest software. How do you do it? Uninstall whatever the software version you have, it's a old. Then go to the Arduino, the web site, install the new latest version of an Arduino IDE to support your Esp8266 add-on. Now, so once you install, so see that you get this type of screen when you run an application. That means that Arduino IDE is being installed in your computer. What is the next thing you have to do? It I have to install what is called Esp8266 add-on. By default, Arduino IDE do not support the Nodemcu development. You have to add what is called Esp8266 add-on. What is the step? The first step, you have to go to the file preferences. So select the file and the preferences. Then, so in that, go to what is called as add-on board manager URLs. There you paste what is called as this index page. So I will show that. So what you have to do is, so as soon as you install, so go to the file, then go to the preferences, click on the preferences. So then go to the add-on manager, additional boards manager here is there. Then paste this URL on that one. I already pasted it. As soon as you paste this one, then say OK. Then what will happen? It gets connected to the then index file. All the required libraries will be installed into this one. So it's very important. This URL you have to copy in the additional board manager. So in the preference settings of Arduino environment, IDE environment. So now I'll close this one. So after doing that one, what is the next step you have to do it? Then go to the open the boards manager, go to tools, the board and the boards manager. So I have to go to the tools, then the board, then the board manager. I have to go there. After that, I have to type in Esp8266. So then you will, among the many things, you'll get Esp8266 by Esp8266 community. Then install that, the library for that. So I'll show that also. So go to the tools, go to the boards. So you have boards is there. So go to the boards manager. So type here. So as soon as it gets installed, so now it's downloading all the latest data from the net. So wait for some time. It's downloading all the latest libraries and indexing. So I have to type here Esp8266. As soon as I type Esp8266 here, so then what will happen? So you will see, so related to Esp8266 from a developer community, just install. In my case, I've already installed. So what I have to do is, let us just type Esp8266. So as soon as I type that one, you can get this one. See that? Now in my case, it's already installed. So if you're not installed, it will appear here. Just say install on the button. So it will get installed into this one. Then close it. So this is the requirement, what you're supposed to do it. So summarizing, add the preferences. So go to the file, go to the additional boards manager URLs, add this, copy this and add to this one. So then include the Esp8266 library. So go in the boards manager and include that library. So then after that, it's ready for programming. Let's build the first program. So what is the first program? So let's connect one LED with a 330 ohm resistor in series with your anode. We can do a breadboard and jumper wise. We can do like this, or we can use the LED which is there already in the board. If at all, let's say I'm going to use an LED which is already there in the board, then what do I do is, so I have to, first of all, in the Arduino, select the board. Among so many boards are there, select Nodemcu 1.0. Always select 1.0 version Nodemcu ESP12E module. So this is the thing I have to do it. So after that, then now connect the board and select the COM port which is required for that. So once you do that, so it is ready for programming. So if at all, if you're connecting an LED outside, use the GPIO pins like in Arduino. So I just connected one LED. The anode is connected to the directly to the pin 2 here, or the D4 on the board, and I have connected the cathode so through a resistor to a ground wire. I just connect to ground. So this board provides 3.3 volts and the ground point, so that you can use to give as a reference or power supply to the your actual circuits. So now let's write a program, a simple sketch to blink the LED. So now we will go to this module. So what I'll do is, so I will connect now see now look at the tools. Now no port is available. Now I'm connecting the board, so which I have with me now, to the laptop. The moment I connected it, you can see that a board COM3 has come. That means that I connected to the board. As you connect the board, you can see that a small that LED blinking you can appears near the Wi-Fi module. That means that the board is proper. Then, so I will select the default program, example programs from the examples. So before that, I'll see that the board is selected. So go to this board, see that already the boards is selected, which is a board Nodemcu 1.0. So this is the thing you have to select it. So I've selected the board, the COM port also I have selected it. Now I have to write one sample program. You can go to the examples, see that ESP8266 is installed. So let's say I'll go to the blink program. Now, so I have got the blink program is ready. So what does this blink program will do it? As you already know that most of you have worked on the program, always we should know that any Arduino program will have two functions which are being part of the one project, or any embedded C program written on the Arduino IDE environment. So the first function name is called as a setup function. So you can put certain code here or functions here, and there's another function called as a loop function. So loop function, you can put other set of codes into here. Summarizing, the Arduino IDE environment provide two default functions. One is called a setup function, other is called a loop function. The setup function, you have to insert here the statements which are going to execute it only one time in the project. That means that whatever you write here, it will execute only one time. And whatever you write in the loop, as the name says, the loop, any embedded system, there is no voice is there. For example, if I ask you the question, this Nodemcu board, does it have an operating system? What is your answer? No. Because why? No voice is there, no Windows, no Linux, nothing is there. Of course, you can put an embedded Linux on the little advanced controller systems, but basic controller board will not have it. Whenever you don't have an OS, after running the code, what you're going to do it? In normal laptops, whenever you launch an app, always goes to where? You always go to the return to the OS. So there somebody is there to return. Whereas in the microcontroller based system, nobody is there. You run the code, nowhere you can return because no OS is there. So that is why what you have to do is keep repeat running the same program until you remove the power from the board. So that is the concept of all embedded system. That means run infinitely some code so that it can implement the logic of your required choice, and no time you should stop. Yes or no? Then only the embedded system can survive, can be breathed. Otherwise, what will happen? It can collapse. It can go to the junk code in the program. So, and it can do unwanted things. That is why we put indefinite loops. So that is why Arduino IDEO, instead of you put a loop, they are provided the function called as loop only. As the name says, loop is what? The set of code is the heart of your embedded system, which should be run continuously to implement the logic of your choice. Because there is no voice is there, so I cannot say return here. That is why the return type of this also void. The return type is also the void. No argument you're passing here. Now, there are 4 standard functions are there in a Node MCU programming, which is similar to your IDE functions are used in the Arduino IDE. No difference is there. But Little variations are there in the resolutions and other things. Let's understand that now. Now, digital pins, whatever you have in Node MCU, or how many pins are there? 11 GPO pins are there. Pin 0 to pin 10. So 11 GPO pins are available. I said one pin on the board is connected to LED default. That's called LED built-in. It's already built in because you have selected Node MCU in the board. So it is automatically 2. The pin number is 2. LED built-in has been default as what? 2. You can give it 2 pin number 2 also here for that. Now, how to use the GPO pins? This is a revision for you since you already know. I just revise it. If you are using GPO pins, they're called as digital pins. You can send to on the digital pins either 1 or 0. So if I am using the digital pins for reading, I can read 1 or 0 from a device connected on the digital pin. Now, so since Arduino IDE is a very abstracted, that means that you don't require how it is implemented, you don't require the microcontroller registers. So which are the GPO registers? How do you set the direction? So how do you set the the mode of that? All those things is not required. That means the GPO pins is there. The set of functions has been already provided in the IDE. That is why it's called like a school children programming. You need not know about the microcontroller when you want to work with a Node MCU or Arduino. Because why? IDE has abstracted everything. You don't require to have the knowledge of the microcontroller, the registers, the bits of the registers and all those things. Because the functions has been developed and been exposed to the application programmer by installing the libraries. The library is already there. Only you should know what is the name of the functions. Now, 4 functions you're supposed to use it whenever you're going to use GPO and analog input output, you do it. Let's learn the GPO. The first function is called digital write. So digital write is a function available in the IDE to configure any pin 1 or 0, for example. So digital write has got 2 arguments. What is the first argument? The pin number. What is the pin number I can give? Pin number 0 to 11 I can specify here. So the pin number 0 to 10 I can specify here. Or I can give a name for the pin and I can use that name here. For example, I can declare here. So I can just say that. So constant integer. So I can say LED. So equals to, I can just specify. So instead of writing LED built in here, I can use the word LED here. Like that, any pin number 0 to 0 to 10, I can give a name for that. I can use that name in the digital write function, or you can indicate the pin number directly. Next, what is the second argument? I can write high or low to make the pin, so what is called as 1 or 0. This is the function of a digital write. Whenever you use a digital write, before start using a GPO pin, you should indicate to the microcontroller, that is ESP8266 microcontroller, the mode of working of this pin. Either pin is used as an input or output. How do you do it? So that is a pin mode function. So pin mode function defines the pin as an input pin or output pin. Since I'm connecting an LED is an output device to me, I just made this pin as an output. Now I'll write digital LED output low. The inbuilt delay function is there. It is a delay in milliseconds. When I say delay 1000, it's a 1 second. When I say delay 2000, it's a 2 seconds. So this is called delay in terms of millisecond. So I call the delay for some time. LED is on. So I'm not sending high, I'm sending low because it's an active low they have used to connect. That means that the pin is connected to the cathode. The other way is cathode. The anode is connected to the 5 volts, or it's a inside. That is when you connect LED on the breadboard, you can connect as a common anode. That means that you can connect the pin to the anode, connect the cathode to the ground. But on the board, they have connected as a common cathode configuration. That is why sending low means LED is on. Sending 1 means LED is so off. So this is called common cathode configuration. Now, digital write, again make the LED button, that is LED, built-in LED, high. High means off. So again, I given a delay. So this is the way I can able to connect any of the output devices using a digital write function, and before that configure them using a pin mode configuration. Let's compile this program and download this program into the kit. So this is the way I'm just compile my program. See that all the libraries are installed. and the board is selected properly, the COM port is also selected properly. Now it's been compiled properly. If there's any errors, it'll show the errors and highlight that line. So you have to correct it and recompile it. So whenever you get an error, line will be highlighted. It'll show that what is the line you got an error. You have to correct it. And unless you get this compilation saying that how many bytes is your code, what is the total memory and all those things, don't go to the next step. Now I've connected the board to the kit, my laptop. I'll upload this program. As I upload, so you can see that. So there is a So I'm uploading the program. So the cable is less. Okay. So I'll just show you this one. Can you see the board with the LED? Can somebody answer?
Yes, sir. Yes, sir.
So I've just downloaded the code, and you can see that it's a 1 second is on, 2 seconds is off. See that it's a more time it's taking for off. Now what I'll do is to make it it's clear. I just go to the program. So I will just change it to make it fast. So I'll make it, let's say, so 500 seconds on and 500 milliseconds, sorry, 500 milliseconds off. So I'll just take it, I'll compile. Now it's compiled successfully. So I'll upload the code. Now the code is getting uploaded. Now you can see that now the speed of blinking is changed because I made it 500 on milliseconds, 500 millisecond off. Can you notice? Yes or no?
Yes, sir.
Yeah. So now, we have understood that how I can able to use my Node MCU kit with this one. So now what I'll do is, now I'll just change the program and start using other things. Similarly, digital input also. Digital input, you can always use it to connect to the switches. So let's go to other program, 1 or 2 programs. Now, digital input and digital output. So we can use what is called digital write and the digital read. Digital read is used to read the digital input devices. Digital write is used for digital output devices like LEDs. We have understood now digital read and write. Now we'll go to that how analog outputs, analog inputs can be accessed using a Node MCU. It's like the same thing as your Arduino also. Let's understand now. Now let's say that I want to control this one. So what I can do is to connect to the A0 input, analog input. I want to connect a sensor. Now, instead of sensor, what I can do is I can use a potentiometer like that. I can vary the pot value and it can generate here. Any potentiometer you take will have a 3 outputs will be there. The one output, the extreme 2 outputs are there to specify what is the voltage range in which you have to generate a voltage. Basically, potentiometer generate a variable voltage as you turn the knob. So extreme pins indicates what is the range of voltage. So I have defined for 3.3 volts. So 3.3 volts pin and the ground I have connected and connect the potentiometer for that. The intermediate pin I have connected to A0 pin. Here I don't have a pot. What I'll do is I'll just take one wire and just short this pin to the VCC or to the ground so that you can get a variable voltage, the range you will get it. Now we will see that how to write a program for this one. So this is the program I just given it. So I will take that program here. So let's see, I will remove this one. So I will take a program. So I've done few programs there. I'll just copy the program and log read program into that. So I want to read from the analog pin and throw to the serial terminal. So I'll copy it here. Okay. So I copied. So what is this pin? Whenever you want to use analog input, in case of a Node MCU, this is the format. A0 is the pin number, is the only A0 possible. In Arduino IDE, you have A0 to A5 is there. Here only one is there, A0 possibility is there. So I'm given a name as analog input pin. You can give anything. So whenever I say analog in pin, I'm reading from A0 pin. So now, since I'm using analog pin, I cannot use a digital read. I'd use analog read. Analog read is another function which has been implemented for accessing analog information from the board. So analog read, only one argument is there. The argument is which is a pin number. In this case, is always A0. Then whatever the value you read from this one, you should be very clear. In case of a digital read, the value what you get is a 0 or 1. In case of a digital write, you can send either 0 or 1. Similarly, in case of analog read, it can return you the following values. What are the values you can return? It can return from 0 to 1023. Why 0 to 1023? Analog input converts analog to digital. So what is the range of input I'm giving? 0 to 3.3 voltage. How much is that correspondingly convert into digital? That depends upon the resolution of the ADC, what you use in the Node MCU. The Node MCU provides 10-bit ADC. So 10-bit means when voltage is 0, all the 10 bits become 0. When the voltage is high, that is 3.3 voltage, the maximum voltage you can supply the analog input, all the 10 bits becomes what? 1, 1, 1, 1, 1. So the 10 bits 1 means correspond what? 2 to the power of 10 minus 1. That is 0 to 1023. So 0 to 1023 is the value which is returned by this function whenever you connect any sensor into A0 pin of Node MCU. So I get a sensor value. Now this indicates some value, some correspond to physical quantity. For example, light. So if there is no light is there, you may get maximum value. If there's a sufficient light, it move towards the 0. That means that if I connect an LDR to the Node MCU module, you get a value 0 to 1023 that indicates how much of light is falling in the LDR. If I connect a temperature sensor like an LM35 to the Node MCU and connect the output of LM35 to the A0 input, this indicates the physical quantity called temperature, 0 to 99 degrees centigrade, like that. So based on this digital value, I can use some formula to convert that into temperature or light intensity, like that. I can convert into physical quantity. Then I can use that physical quantity in the program for storage, for analysis, for display, or uploading to the cloud value. One of the best method to start with is you can show or throw that value into local monitor. What is meant by local monitor? That means that the Node MCU has got two pins called TXD and RXT Uart. So that is connected to your laptop using USB cable. So that means that there is a facility is there in the Node MCU module to throw the data to the computer and catch in the terminal. So the Arduino IDE provides what is called as a terminal program. So you have what is called as, so terminal is there. I can open the terminal like a serial monitor. We call it serial monitor. Whenever you open the serial monitor, whatever the data, so which has been thrown from the Node MCU is being catched there. This is a way to debug embedded systems. So serial throwing the data from the microcontroller or from the Node MCU module is a way to debug your projects. In between the code, keep printing some data in between somewhere. So after 5 lines, so throw some data. After 5 lines, throw some data so that you know that, oh, till this point, the program has worked. So for extensive debugging, people use serial monitor and serial communication now. How do you start the serial communication? First of all, configure your serial communication baud rate. As I said, Uart protocol requires the baud rate specification, unlike I2c and SPI. Here I've used the maximum 1,15,200. So this is a statement. You're supposed to write it. So whenever you want to use a serial communication. So since I'm not using an LED, I don't require this line at all. So no LEDs connected, it's not required. So what I'm doing here, I'm just enabling the serial communication. This is only one time to set the baud rate, only one time in the beginning. That's why I put in the setup. Now what I'm doing is I'm reading the value, digital value of the sensor which is connected to A0 input. I'm printing that value in the serial monitor. So what I have done here, I'm just printing it. I'm getting a delay of 1 second again. This is repeatedly executed. We will see that now what will happen. So now I am not connected in the board. You can see that I am not connected here. I'll physically take one wire. So I can just use some wire like this. So you can just see that I've used small wire. So I'll short this wire to the pin A0 to ground at VCC. So to varies that. So now I'll compile this program. So now I compiled the program. There was no error. So I'll just upload the code into that. Now LED blinking stops because I've not written the program for LED blinking. So now it's writing the code. Now I'll open the, see that LED blinking will stop. Stop now. There is no LED blinking because I stopped the code for that. Now the program is running and I'm printing the data on the serial monitor. So I'll go to the tools. I'll open the serial monitor. You can see on the serial monitor, data is printing some random data because A0 is not connected to anywhere. So now what I'll do is I'll take the wire, just short the pin A0 to 3.3 voltage. So 3.3 means around 1023 you're supposed to get it. I'll just do that one manually. You can see that. So what I've done is I've just shorted the wire. I've shorted the wire and you got few values as 1024. So like this, you can always use it and you can able to program that. So this is how you can able to use a sensor module and you can able to connect that one. So this is what I've done now. So I have used a small wire and just shorted that one. So you got the values 1024 like that. 1024. So it's a maximum value. So, okay, I'll close the serial terminal now. So now we finished understanding this, how analog read is there. Now let's understand how do you generate analog output work for this. Now, so let's go to another program now. So these are the different values, what I got it. So you can always use a map function. So to map the values, for example, whatever the value you read it here, you can map in the range what you require. For example, so I can map from 0 to 1022, 0 to 255 like that. So the range of the input, the whatever you're getting from the analog read, you can map to other values. You can always use this method. You can do it. So now I'm going to use what is called as the PWM nature of the GPU pin. So I said there is no analog output pins are available here, but the GPU pins, you can use them as PWM pins. So what I have done, all these pins I can use. So there's a pin 2, but in the board it's called as a D4. I can use to generate as a PWM waveform. So what is a PWM waveform? We know that PWM waveform is nothing but if you plot it, it's on plus off. This is called one cycle. So this is called as a PWM waveform. So whenever you have a PWM waveform, it's called as one cycle. So one cycle consists of on time plus off time. On plus off is called as one cycle. So this type of waveform, when you generate it, effectively you are varying the voltage at the pin from 0 to maximum voltage supported by that microcontroller. For example, in this case, 3.3. So that means that if the on time is more, the voltage is what? Towards the 3.3 voltage. If the on time is less, the voltage is what? Towards the 0 voltage. That means that if I make it continuously on, so what you get on the output? We know that whenever it's 1, it's always 3.3. Whenever it's 0, it's always 0. If I want to produce on this pin any voltage or simulate, I'm not telling that it's an actual analog. You're basically simulating by generating a frequency, continuous waveform. So if you want to simulate any voltage on this pin, which varies from 0 to 3.3 voltage, so that I can vary the brightness of an LED, or I can drive the DC motor running at different speeds. All this is possible whenever I vary the voltage at a pin. How do I vary the voltage at a pin? Instead of making just 1 and 0 using a digital write, you use a method to generate a continuous waveform where the on time can be variable. Whenever the on time is varying, we say called as duty cycle of this waveform changes. So what is the duty cycle? On divided by on plus off. It's called as a duty cycle. When the duty cycle is 100%, the waveform is what? 3.3 voltage. It produces in the pin 3.3 voltage. Whenever the duty cycle is towards 0, it produces what voltage? 0 voltage. So like this, a normal digital output pin, using the PWM concept, we can simulate analog output voltage. So now this has been already implemented in the IDE. So we have to just call that function. Now what I've done, I connected an LED. Now at the moment I'm using the LED what is present already in the board that is connected to the same pin number 2. So what is the program I'm writing? So I'm writing a program. I'll just use that program. So I'll just copy that program. So I'm simulating. I'm simulating the code for that now. So what is I'm doing now? I'm using function called analog write. Analog write is the function to simulate 0 to 3.3 voltage on any of the GPU pins. Here almost all the pins supports that one. You can verify always using the data sheet of the whichever the Node MCU model you use. So which are the pin supports here? The pin number 2 supports PWM. So I'm using that one. So I've given a name, the LED pin to the pin number 2. So I'm using analog write. To the pin number 2, I'm writing the duty cycle. So this function expects the second argument is how much of duty cycle you require. So you can vary this duty cycle from 0 to 1023. So if it's 1023, you give it here, it's the highest. That means that 100% duty cycle. It's a 3.3 voltage you get on the pin. If the duty cycle 0, you get a 0 voltage. That means that PWM is disabled. So I'm using a for loop to vary the duty cycle from 0 to 1023, and just write that vary voltage from 0 to 3.3 with a delay of 1. Another for loop I written to reduce from 1023 to 0 and decrease the intensity. When I read this function, when I run this program, so you can get the LED brightness increasing and decreasing gradually. So now I'll compile this program. You can compile this program. You can just verify that the LED brightness varies. So now I compiled. Now I upload the code. Now you can see that LED brightness increasing and decreasing. So the PWM concept has been used to generate varying voltage, which controls the LED brightness. You can control the speed of the DC motor if you connect the same P2 motor. Is it visible?
Yes, sir. It's
Yes,
visible.
sir. Yes, sir.
Okay. So this completes about the basics about how you can use the four popular functions of Nodemcu IDE using Arduino IDE. So now, so this completes about how you can use the functions. So related to analog, right? You can always generally the PWM, what is the generated. So there is a waveform will be there. Waveform frequency will be there. How fast the frequency generates. This is called as analog. Right, when you use PWM frequency, you can set this one. By default, it's a they've used 1 kilohertz frequency. So for example, if you want to connect a DC motor, it generally works better around 10 to 15 kilohertz. Then you have to change the frequency of this one. Duty cycle is different, frequency is different. So frequency is the rate of generating of these cycles. So duty cycle is how much is on time in a given cycle. So that frequency you can change it using this one function called analog write function. So when you use a DC motors or servo motors, see that what is the frequency you require. Then you can set the frequency. So how fast it rotates, correct? No, that depends upon so your duty cycle. So this completes about the basics of Nodemcu, what pins are available, how to program those pins, and write embedded system programming or interfacing the sensors, and you can able to connect it. So once we complete this one, now we will move to the next level of the Nodemcu. So what is that required now? Now I want to connect a sensor to the Nodemcu and gather from the sensor the data. Let's learn that one now. So I'll be now connecting a popular sensor, so which is called as a DHT11 sensor, so which is used to establish a connection between the Nodemcu module and the sensor with a one-line communication. It's called a one-line serial communication. It is not I2c, it's not Uart, it's not SPO also. Sometimes most of the legacy or the traditional sensors, they use a one-line communication. When I say one-line communication, you can look at here. There is only one pin is available. So I'll go to the directly the LCU. Okay, you can see that there are 3 pins are available. 2 pins are available for supplying the power to this board. So supplying that power to this board. So I'll just indicate that one. So this is the supplying the power to this board, that is VCC and the ground. You have to connect it. Now there's a 1 pin is available. This single pin establishes communication to your Nodemcu module. So the lot of sensors are available like this, which are single pin compatible or single pin serial protocol this supports. Then how do you do that one? So for that, you have to write a big program, understand the protocol, how it has been implemented in this sensor board, and then you have to use this pin, because this pin is used for what? For some time sending the data. Same pin is used for some time what? Reading the data. So there's a fixed time is there. You initialize the sensor, give some specific time, wait for that amount of time, then it starts sending the data, collect the data. So this is the protocol you have to implement whenever you use this type of sensor. There's a lot of sensors. There's temperature sensors available. The beauty of these type of sensors is only one line is good enough. So you don't require much of the lines. Even if you use Uart, it requires what? 2 lines, TXD and RXD required. And I2c also 2 lines are required. So here it is, one line is good enough. So whenever you have such sensors are there, so please look into the project. That means that you cannot write the whole code. It's a big code, you're supposed to write it. Look for the libraries available in the market for those sensors. So what the library is available, you have to include or install that library in your IDE. Then you can start using that one. So what you have to do is, if at all, if you connect any sensor for the Node MCU, first look for the libraries for that sensor. Install that library into the IDE, then start using that module into your project. This is a common for every sensors you connect to this one, except if the sensor is directly connected to the A0. For example, LDR directly generates a voltage, connect to A0 pin, like whatever we did in the earlier program, do like that one. If, for example, use LM35 temperature sensor, directly it gives the voltage 0 to 3.3, connect directly to the A0 input. So if you have a module which is little intelligent, this is intelligent because there is a controller is present inside here. Inside the controller is there. So which establishes a protocol. In such cases, you cannot write a program. It's a big program. You're supposed to write it. So install a library. Always you have to think that A0 is used, no library is required. When A0 is not used, a protocol is there, install the library. So now I've installed the library for this one. So what are the pins required for this? So DHT11 provides the 3 pins. So one is an out pins, that is pin number of 7. You can connect to the Nodemcu or Raspberry Pi. So I just indicated here RPi. So digital DHT11 sensor, it's a, how does the data thrown from the DHT11 sensor? It's a digital sensor because it gives the data in terms of ones and zeros. So whenever it's a digital sensor, you have to connect to what? 11, any one of the 11 GPIO pins you're supposed to connect it. Once you initiate the sensor, it throws 40 bit of data. What is the data comprised of? It's a RH and RH decimal data. That means that what? Humidity. First it throw 16 bit of humidity data. It's a decimal value. So it has got a decimal value. That's why 8 bits in integer, 8 bits in decimal. 25.67 like that. First it shows the integer portion, then the decimal portion. Then it throws the temperature. That is also a decimal value. First it shows the integer portion, then the decimal portion. So 16 bit for humidity, 16 bit for temperature, and 8 bit for checksum to make sure that this 40 bit data is being transferred properly to the other side. That is a Node MCU. So this 40 bit data you have to extract in the Node MCU module to extract your temperature and your humidity. So again, since you already installed a library, the library provides the functions which done extraction of this data from this 40 bit data. So it's only thing I should know what are the name of the functions. Now I made a connections. I taken the Node MCU. I connected ground and the VCC to the DHT11. I connected only one pin to the GPIO 14. I've connected D5. We connected. So on the board, it's a different pin number. For the chip, it's a different pin number. You should note down that connected. And so pull up to that point to 5 volts. It's very, very important. Whenever you in a single pin protocols are implemented in a sensor, make sure that the pin sometimes require pulling up the voltage. Here pull up is done. What is the pull up done? The output pin I have connected through a resistor to the 5 volts, other 3.3 volts in this case. So that when there is no data is available, if you take the multimeter and measure this point, you should get a high. So that is a prerequisite. So make sure that this type of pull up or pull down resistors to be used whenever you use sensors with the single line protocols. So I also connected an LCD to display. So if required, you can also connect like this. Now, so I'll go to the next one. I have to install the DHT11 sensor module. So we know that in the Arduino, what you have to do first, go to the Arduino IDE, go to the sketch, include library, manage libraries. So the library manager should open. So what I have done, sketch, include library, manage libraries. In that, I have to type DHT11. So whenever, so we did the same thing for ESP8266 also. So then you get the library name. So just install that library. I have installed in my system. Similarly, after installing, so DHT library from Adafruit, type Adafruit unified sensor in the search box, scroll all the way down to find the library and install it. So I've just done this one. I've used so Adafruit unified sensor by Adafruit company. I've installed. So now after installing that one, now I can start writing my code. Now what is the way to write a code? First of all, since you included a library, include the header file corresponding to that one. So what is that number? So include DHT11. So that's the library. I've installed it. Next. So now you have to decide which is the pin, GPIO pin you used to connect to the DHT11. Here I have to use the actual pin, GPIO pin of the ESP8266 pin, not the board pin. So 14 is used. So that is why 14 I have given it. This is very important. Next, create an object of a DHT11 sensor. So create an object DHT. DHT class is already included because you included a library and the header files is included here, and indicate. So which is the GPIO pin of Nodemcu you're using to read the output of the sensor. That is a DHT pin. The pin is 14. So this DHT sensors is of two types. DHT11, DHT22 is available. If you want a more resolution, more temperature range is required, go for DHT22. If the range is 0 to 90 degrees, like that normal room temperature, so don't go for DHT22. It's a costly. You can go for DHT11. You can go for it. So that is a type indicated here. Here is indicated 22. You can make it 11 also. Now setup. So install start the object related to the DHT sensor. So DHT.begin. That means that object is ready. Now it can communicate. The Nodemcu can communicate with the DHT11 sensor. So first is what I said. As soon as you include a library, the functions are provided as a part of this object. DHT.read temperature means what? It gives a float value. So because I said it's a decimal value. So then read humidity, you get what? H value. Now I finished. Now just print that in the serial port. So that's all you have to do. It. Just purchase the DHT11 sensor in the market, connect the two pins to the VCC in ground, connect the third pin into what? So the whichever the GPIO pin you require it, install the DHT11 library and write this code. This is all the code you're supposed to write it. And just run this program. You can get your room temperature and the humidity in the serial port. So this completes how sensors can be integrated to the Nodemcu module. So now, we have learned how to use the GPIO pins, how to use analog pins, how to use sensors and interface to the Nodemcu board. Now, am I clear? Am I audible? Hello.
Yes, sir. Yes, sir.
Yeah. Okay. So now we will continue from there. Now to make it IoT enablement, that means that Nodemcu side, I've understood everything. I know how to use an ID and everything. I want to throw this data to a cloud. That's a part of any IoT enablement. There's number of clouds available in the market. Number of clouds are there. IoT clouds are available. We found from our experience in the last few years in the lab experiments or the projects we conduct, Thingspeak is one of the beautiful IoT cloud platform available free with certain restrictions, but you can integrate into this one. Whenever you say IoT cloud, two jobs are there. Cloud means what? A remote place where your data can be accumulated. When I say cloud, the accuracy, availability, and the what is called as reliability is very high. In the sense, if a normal computer you use, the chances of getting hanged or the power problem is there, battery problem, all that is there. But in the cloud, they would have set up a big data centers. A lot of money is invested in the backup. A lot of money is invested in the redundancy. That means that if one computer goes down, another computer is up, like that. So whenever you depend on the cloud, the reliability and the availability is always more compared to your desktop computers or the normal laptops, whatever you use in the house. That is why we always prefer storing the data on the cloud, which is more reliable and more available compared to your normal local storage. That is why whenever you build a project, whenever you propose some value addition to your customers, always suggest the cloud because that's a more reliable. Only thing is the money part is there and the amount you have to spend on what is called transmission, that is the bandwidth you should have it. Those challenges are there, but still it's a more reliable and more the model which is going to have the value in the future. Because local storage means there's no much value for your project. When you put that in the cloud, the value for your product is more. So what I do here, I have to choose any cloud. See, any cloud can you call as an IoT cloud? You can call as an IoT cloud. But only thing is, how much of program you supposed to write manually in that cloud to support your IoT environment with the product is a question comes into picture. If there is a pure cloud is there for which gives the storage space or the machine it gives us virtual machine, you have to write the code and everything. That means that you have to do a lot of work on your side to give the IoT enablement. But there are certain clouds, they already inbuilt programs are there. The facility for you is there to upload your data, to download the data. Then such clouds are called as IoT clouds. So IoT clouds enables easy connecting of your device to the cloud by providing set of functions or libraries for uploading and downloading the data. So Thingspeak is such one IoT platform. So our IoT cloud. So two things you can do with this IoT cloud, Thingspeak. Number one, you can store your data. Number two, you can download the data whenever, wherever, through whichever means required. So when I say wherever, what does it mean? That you would have uploaded the data in Bangalore, you could have downloaded the data in San Francisco, you can do it. And I say that any means, what does it mean? That you can download the data into your mobile phone, you can download into a laptop and analyze the data in a Java programming language. That means that how do you upload? Upload the data using embedded C and then download using Java program. So that means that any means you can use it for uploading and downloading the data. So that is a facility provided by your Thingspeak IoT cloud. Second, I said you can do a computations. See, cloud is basically used for two things. Only for storage. That's what you do in a Google Drive or a Dropbox. You just store it. But if you take Amazon cloud like an AWS or Thingspeak like that purpose, you can set up what is called computation also on your data. That means that you can write certain code on the cloud. As soon as I get the data, it can run, your program can run, or you can run program every day in the morning for 1 hour, process the data, whatever there and that. It can send some information to your mobile. You can send an email like that. If the computation is enabled, then the cloud is better for you. Because why? You can do certain things on that. That is why when the choice compute in the Firebase or the Thingspeak or the AWS or a normal Google Drive, you should always think that you want only storage, uploading and downloading of data is required, or you want certain computation should happen in the cloud. I have chosen Thingspeak because I can do both the things. I can store my data here, and also I can do certain computations on the data which is stored here. Whenever I want to do computation, there's a language is required to access your data and everything. So they support what's called MATLAB analytics. You know the MATLAB. So MATLAB is a C-like code. You can write it. A lot of functions are there. You can do the loops. You can find out algorithm. You can write small function, mathematical functions on the data. So you don't require a MATLAB. When you use a Thingspeak, on the cloud itself, MATLAB is implemented. You can just write the code and link the data, and it runs on the data as there in the cloud. So the beauty of Thingspeak is what? Storage plus MATLAB code can run on your data. Both is possible here. So now, having understood the advantage of the cloud, IoT cloud called Thingspeak, let's learn how to create channels, how to store the data. Now, so whatever the steps I'm going to tell you, you can also try immediately after the class and create your own channels today itself. Now, so first of all, how do you start accessing the Thingspeak? You should create a sign up. You should sign up it. Just give your email ID. Then immediately your sign up is accepted and you are accessible to Thingspeak. Now, how does the Thingspeak works? What does it provide for you once you sign up for the Thingspeak? It provides what is called as the storage for your data. That means that all the Nodemcu devices, the many number of Nodemcu devices, they may be connected to the internet using a router. In your case, you not have a router itself. The mobile itself is a router. The mobile hotspot. When you make a mobile hotspot, this is your router. This is your Nodemcu. So Nodemcu connected to the mobile hotspot, and the program on the Nodemcu which access the Thingspeak sends the data to the Thingspeak. Then what will happen? Thingspeak, anyway, you have created a login. You should establish connection between your Nodemcu and the Thingspeak. That's what we have to do it. So now, once you sign in, it provides a facility for this connection. How does it provide a connection? We will learn that. So Thingspeak, basically, there's some salient point to Thingspeak. So IoT is nothing but collection of objects and other physical devices, which is embedded with sensors and actuators. It helps to connect the different objects and exchange data. Each object is embedded in embedded computing system, is uniquely identifiable and can operate with existing infrastructure. Thingspeak is an open source IoT application and API to store and retrieve data from things using an HTTP protocol over the internet or via local area network. Thingspeak was originally launched by IOBridge in 2010 as a service in support of IoT applications. Thingspeak has integrated support from the numerical computing software MATLAB, allowing Thingspeak users to analyze and visualize the uploaded data. So we will learn about these little details. Okay, what are the things you have to do? So go to the thingspeak.com, sign up for that. So if you have already a MATLAB account, so you can just use that. Otherwise, you can just sign up by giving your email ID. So once you have signed up, then how do you log into the Thingspeak? Just go to thingspeak.com, just specify your email ID and give a password. The moment you sign in, so you get, this is the screen you're going to get. Sign up for the Thingspeak and then you're going to get this screen. Now, as soon as you get this screen, as you sign up, what are the things you have to do? Where do you store the data? Data is stored in a name called channels. So channels is the way to store your channel. For example, myself, I have one channel. There's a number called, they will allot a number. Maybe 10,333 is my channel. Tomorrow you create a sign up for this one. They will allot a channel. 10,533 is a channel for you. That means that every channel has got a unique number. That number is allotted for every signed user. So channel is the way to store your data. For example, I want to see the data in your channel. I can just say, specify what? I can just say thingspeak.com/ the channel number, enter. If I give it, I'll go to directly that channel. It shows the data. So you can make the channels public or you can make it private. When I make a channel as a public, that means that anybody can see the data available in that channel. For example, there are a lot of channels are being public available for temperature of a particular cities and everything. So what you do, just identify what is the channel number, go to thingspeak.com/ channel number, enter. Immediately you can see the data. So it is left to the programmer or to the user to make the channel as a private or a public. So now, as soon as you logged in, it gives a channel. Then first time, channel will not be there. You have to create a channel. Then you click on the new channel. The moment you click on the new channel, then what will happen? Channel number will be available for you. So now, as soon as you create a channel, then what does the channel consist of? Channel will have a name. You can give a name. For example, temperature monitoring system, a smart system. So a sensor deployed at a particular village. Like you can give a name for that. You can give a description for that also. Every channel will have fields. The channel, how does it store the data? Channel stores the data in the fields. Every field is like an Excel column. In Excel sheet, if you create a tabular column, what do you have? Number of columns will be there. Each column will have number of data which has been for different rows. So row 0, column 1, row 2, column 1, like that. Every column will have a multiple sets of data which is distinguished by the rows. Similarly, the fields. So every channel will have a multiple fields will be there. Up to 8 fields are there for you. Each of the fields is have a different name. What is the name? Field 1, 1, 2, 3, 8, like that. So once you have a set of data, for example, I am collecting a temperature. What you can do is, in this channel, new channel, I can store the data in a particular field. For example, I'll use the field 1 for temperature. Then keep putting the data in the field. First data you send to the field 1, it will be in the row 1. Send the second data, it will go to the row 2, row 3, like that. The data is added as row 0, row 1, row 2, row 3, like that, indefinitely and infinitely into a particular field. For example, I want to record the moisture also. Then store them in the field 2. Like that, 8 different fields are there, which you can use to represent 8 different sensors or something else. It depends upon your choice. There is no restrictions are there. So whenever you want to store the data into the ThingsSpeak, what do you require? I should know the name of my channel or the number of the channel and which field I'm supposed to write. That's all the information I require it. Now, so once I created this channel, now, so what I'll do is I'll just I'll go to the channel itself. I've just opened my channel and just show you how the channel looks. So this is the channel, ThingsSpeak channel, which I created for watching the weather monitoring for MCS, microcontroller embedded system, some lab I created, weather monitoring. So what is the channel? Channel ID is what? 10.10.4553 is the channel. So I made it a private view. That means that only I can choose it. Others cannot access this channel. If I say enter this channel thingspeak.com, like this channel number, it will not allow you because it's a private. By making it public, so you can allow for others to use this. So this is the channels I have just created. So this is a channel status. So these are the things I've added it. You can also add it. So now as soon as you create a channel, you can see this one. You can see on this one. So what this is, there's a screen. You can see that channel settings. So give a name for that. So I choose two things. Field 1 I enabled. Field 2 I enabled it. I call this, the name of this is a temperature. I call the name of this is humidity. My channel name is what? MK weather monitoring. So channel name is weather monitoring. The first field name is temperature. Second field name is humidity. This is all you have to do it. Now what is my channel number? 10.045553. Now, so now I have created what is required on the ThingsSpeak cloud. So by signing in, creating a channel, new channel, giving a name for it, choosing the number of fields for that. Now it's ready. That means that storage and computation on this channel is enabled. Now what should I do it now? Next thing, how do I establish a communication between your ThingsSpeak channel and the Node MCU? That means that let's take the first case. I have already collected the data from a sensor, temperature sensor and humidity sensor, temperature, humidity. I have to throw this data into this one. How do you do it? So you can do that one by using what is called as APIs. You should know what is called as API keys. So API keys is the way to secure your data. So don't capture the screen now because it's secured. So I have to, the moment you go to the API keys, it will generate the two keys. One is for the write API key, other is called as the read API keys. It will generate. This is a very secure, don't show to anybody. So copy these keys into one of the notepad. So that means that this is the write key and the read API key. So now, so I'll go back to the PowerPoint presentation. Okay, so look at here. Now, once you know what are the channel ID and the write key and the read API keys, copy them into one of the notepad file because this is very secure. It's required. Don't show to anybody these keys. So once you have these keys are the way to get connect to your channel from the Node MCU. Then what is the next step I'm supposed to do it? So now, so I have created all these things. So now I'm going to write my program. So how do we start writing my program? So I'll start my program like this. So first you have to do what? You have to create a library of ThingsSpeak in your Node MCU. Similarly, that like a DH11 sensor module, ThingsSpeak library also you have to install. Go to the libraries, type ThingsSpeak and install the library for that. So once that is installed, so you can start using that one. If you got any doubt about how to install the library, so documentation for the ThingsSpeak communication library for the Arduino is in the readme.md folder where the library was installed. You can go through that one. You can install this one. Once it's installed, then what you have to do is, so instead of creating the IDs in a openly in the .c program, so I will create a separate secrets.h file and keep my IDs. What are the two important IDs required? One is a write API key is required. If I want to upload the data from Node MCU to your cloud, so I say define secret write API key XYZ. Instead of XYZ, copy the write API key into this position, replace it. Since you want to connect your Node MCU to the mobile hotspot as a router so that internet connectivity is available, you just go to the hotspot of your mobile. There is two things are there. One is a password, SSID will be there. Copy from the hotspot of your mobile, the ID and the password. So put them in a secrets.h file. Now my file is ready. So I got a secret information about hotspot and also about API keys of the ThingsSpeak ready. Then, so what you have to do is after that, I start write the code in the Arduino. What is the code? Include thingspeak.h header file, because this file is required to access the library function of ThingsSpeak. What are the library functions required? Upload to the cloud. I require a function. That's why I include this one. Include secrets.h. When I say double quote here, that means that in the same directory where I've written the code, you include this file. Create a file and put it in the same directory. And since you require ESP8266 Wi-Fi.h, you are using a Wi-Fi enablement, including a library ESP8266 Wi-Fi.h. Whenever Wi-Fi connectivity of ESP8266 is required, you have to require this file. And if you require what is called as DH11, include the DH11 library also. So I'm not included here, you can include that. So you can combine that program. So now I created two arrays. One is SSID, other is a password. So these contents are defined from what? These two hash defined constants are defined in the secret.h file. So that the people who look at the program, so immediately they will not look at your ID and the password. So that is why some protection you can provide. So because you would have included that in the secrets.h file. Always do like this. Then create a Wi-Fi client because you want to communicate from the Node MCU to the your modem. Modem is in the sense your mobile phone. So create a Wi-Fi client. Then I have written my channel number again, which has been defined in the secret.h file. What is my API key? I have just declared it. These are the two variables I've set up. So from the secret.h file, whatever I defined, I just put into the variables. So what are the variables I created? SSID is one variable, password is other variable, my channel number other variable, my radio peak is another variable. Now, after that, my program starts. So first, what does I have to do in the setup program? Make sure that Wi-Fi is get connected to your Node MCU. That means that begin the communication, Wi-Fi communication at 1,15,200 baud rate. This is by default. These are the values has been set. That is why I set that. Set the Wi-Fi mode to Wi-Fi station mode. We will discuss about this tomorrow a little more. Wi-Fi station mode. Now begin the ThingsSpeak object. So which has been installed already as a library. You just start that one. So now this is what is you do in the setup. So once you start this one, now you start writing the program. What is the program? Throw the data of temperature and the humidity to the cloud. How do we do it? So the first part of the loop program is Wi-Fi connectivity always should be there. By chance, what will happen? If the connectivity is not there, its program will work for some time. After that, it disconnects. That's why the first part of the loop program is repeatedly check in the loop. If it's connected, don't do anything. If it's not connected, be in the loop and get connected. This is the logic what we are returning. So this is very essential to remain always in the Wi-Fi connection. By chance, if it's disconnected, get connected everything. So this is the first part of the loop program. The second part of the loop program is what? Collect the data. Now in this case, what is the number one? It's a temperature. Number two is what? The humidity, which we have read from the DH11. So ThingsSpeak provides what is called set field function. Through that, I can choose which is a field in the ThingsSpeak channel I have to upload. So now channel 1, which is temperature, is uploaded with the temperature. Channel 2, the field 2 of the channel, so which has been uploaded with the humidity. Like this, using this function, upload to ThinkCloud. The moment you execute these statements, you just parallelly observe the ThingsSpeak. So immediately you got two data values into those fields. You can see that clearly, that the plotting of the graph, you can see that. Now, so you can also send some message in the ThingsSpeak also. I just indicated if the number 1 is greater, field 1 is greater. If the number 1 is less than, field is 2 greater. So how do you update the status? Set status. So you can see that status also. Some information is displayed there also. So now this is a code for what? Uploading my data to the ThingsSpeak cloud. So I have uploaded the data. Now, after uploading that, so I have not uploaded here. I have just done what? Set the fields. Set the fields is only not uploaded still. It just set the value to the fields. Now, how do you upload? So write fields is uploading function. So when I say write fields, all the multiple fields, whatever you all been assigned the values using a set field function, will be returned to a fields of a channel number which you have assigned to this variable, my channel number. So now it is done. So whenever you use this function, what is important? My write API key is very important, because you are writing into a remote channel. What is the security? My write API key is the security. Using this security, you can upload the data to the channel which is available at a remote place in the remote computer. Now it returns some number. If the number is 200, that means the channel update is successful. If not, the number is 200, there are certain error codes there. You can display and identify where is an error. You can do it. So if there is a number is different, you can just print that on the serial monitor. Now I just, in the loop, without the sensor, I just given some program here, random 0 to 100, random 0. So randomly I'm generating it. If you have really sensor is connected, you don't require this one. Just put a sensor code here, replace that sensor code, and just run this program in a loop. So now after running this program, so you just download the code, this code, and see that the beautifully on the channels, you can see that the data will be varying. So you can go to the private view and you can automatically the charts will appear here and they say uploading the data will come like this. You can create a widget, so and all those things. You can do some processing of this data and you can export this data, download this data into an Excel file and do further analysis. Or you can write a small application app, mobile app. I can access this data, I can pull the data into the app and show in the app also. Or you can write some Java code in a computer, pull this data. They provide APIs for the Java, other language also. You can pull the data and store in a local computer for further analysis. Doing AI and machine learning, you require a lot of historical data is required. So this is the way you can collect the data for the processing of your AML algorithms. So this completes today's session about how to prototype using a Node MCU and the cloud. So if you have any doubt, you can just raise your doubts. Was it useful? Was the session was useful?
Yes, sir. It was very helpful for the projects and
Okay.
in further.
So immediately purchase one Node MCU, connect a Thingspeak, you just upload. It works within half a day of your effort. It's good enough. You can able to experiment it. I'll share the material, video and everything. I think another half day if you sit, you can finish one project, weather monitoring system you can finish. So if any doubt, you can just raise your doubts. I'll stop the recording.